Dear students, I am Nilanjana Sanyal, an online math tutor from India. I tutor students of the IB and the IGCSE boards from grades 9 to 12. This is my website www.nsonlinemathtutoring.com. You may visit my website to know about my tutoring services in more detail. Okay. Now our today's topic is depreciation. We will be learning this topic using the geometric sequences. Okay. And this topic, depreciation, is very much similar to our previous video's topic, the growth and decay topic. This one is related similar to the decay model. The only difference is that for a decay model, it is not necessarily always attached to some monetary value, but the depreciation is almost always related to some monetary value. That is the only difference. We have seen in the decay model, we have seen that radioactive substances, they decrease in their masses. That is not associated with some money or value. Okay. The mass is getting changed with time. That is the decay model. This is also, decay means it is a decreasing thing, something is decreasing, and in this case the value is decreasing in the case of depreciation. Okay. So assets such as computers, cars, furniture lose value as time passes. Now for furniture, there are antique furniture which increase in value. Their value increases as time passes. But those are special cases. In general, computers, cars, furniture, these things lose value as time passes. This is due to the wear and tear, the technology becoming obsolete or old, and due to other reasons. Okay. So, other reasons means there are personal tastes which differ from time to time. That may be one of the reasons as well. There are so many other reasons. Okay. So, depreciation is the loss in the value of an item over time. And what is the formula for depreciation? U0 is the initial value of the object. This is having a subscript 0 because it is related to the starting time, the time 0. So, it is having a subscript 0. So, U0 is the initial value of the object. D is the rate of depreciation per annum. This is important. Per annum. Okay. And UN is the value of the object after n years. And the depreciation equation is UN is equal to U0 times 1 minus D to the power of n. This is actually similar or the same thing that we had learned in our previous video related to the growth and decay model. It was UN is equal to U0 R to the power of n. We have learnt about this in our last video. What difference are we seeing? Instead of R, we are having this expression 1 minus D. And in case you have watched my last video, you have seen that how was I getting the value of R when it was decaying or decreasing? The percentage that was given, first of all, I was converting that percentage to a decimal number, and I was subtracting that decimal number from 1. That was the thing that I was doing in order to get the R value. And that is exactly the same thing over here, written over here. D over here is in decimal format and it is getting subtracted from 1. Okay. So, there is no difference between this equation, this relation and this relation. Okay. So, now let us try to solve one or two questions on this depreciation topic. Okay. The first question says a tractor was purchased for 110,000 euros and depreciates at 25% per annum for 5 years. Subpart A is find its value at the end of this period, that is at the end of 5 years, and subpart B says by how much has it depreciated. Okay, so let's start with our answer. Was purchased for 110,000 euros. So U0 is equal to, I'm not writing the unit, I'll be writing the unit as my final answer. When I'll be giving the final answer, I'll be writing the unit. Okay. So for calculation purposes, I'm just omitting the unit, and it is 110,000 is the U0, and N is equal to 5. D is equal to 25%, that is 25 over 100. Converted to a decimal number, we get the value of D as 0.25. Okay. Now we have to get the value of UN. So UN will be UN, which in this case, since N is 5, we may write UN or we may write U5. This should be equal to U0 times 1 minus D to the power of N, which is equal to 5. So this is U0 is 110,000 and 1 minus D is 0.25. 1 minus 0.25 is 0.75. Okay. To the power of 5. So let us find out the value of U5. It will be in euros. So we have to get the calculator. So it is 110,000 times 0.75 to the power of 5. 26103.516. So we may take 26103.5. Okay. 26103.5. Let me check once more. 26103.5. Okay. So this is our value of the tractor after 5 years. It was purchased with these many euros, 110,000 euros, and after 5 years, its value is only 26,103.5 euros. If that person wants to sell this tractor, of course he may make some profit, else he will be getting only this value for the tractor. Okay. So this gives us the answer for the subpart A, and we write this answer for the subpart A. It is 26,103.5 euros. This is our answer. And by how much has it depreciated? Subpart B. So depreciation is equal to 110,000 minus 26,103.5. That is equal to 110,000 minus 26,103.5, okay, equal to 83896.5, okay, 83896.5. So it is 83,896.5 euros is the depreciation. Okay, 83,896.5 euros is the depreciation value. So let me try to write it over here. 83,896.5. This is the depreciation amount. Okay. So we are done with the question 1. Let us move on to the next question. A printing press costing $250,000 was sold 4 years later for $80,000. Obviously, previously it was costing $250,000 and now after 4 years it is only $80,000. At what yearly rate, per annum rate, did it depreciate in value? So, answer. The original value was 250,000 and the final cost is UN is equal to, or U4, whatever you write. So that is equal to 80,000. And N is equal to 4. We have to find the value of D. D is equal to what? So we just apply this equation. UN is equal to U0 times 1 minus D to the power of N. Now we just substitute the values. 80,000. In place of UN, I am writing 80,000. This should be equal to U0 is 250,000. And 1 minus D, N is equal to 4. Okay. So, 1 minus D to the power of 4 should be equal to 80,000 over 250,000. Okay. We can cancel these also. 8 over 25, what is that equal to? 8 divided by 25. 0.32. This is equal to 0.32. Okay. So, 1 minus D will be equal to the 4th root of 0.32. This can be written as 0.32 to the power of 1 over 4 or 0.32. 1 over 4 is 0.25. So, I can write, it is 0.32. 1 over 4 can be written as 0.25. Okay. We can keep it as 1/4 as well, but I think instead of writing a fraction in the power part, it is easier to type in the decimal format. Okay, so that is the only reason that I am converting the 1/4 to 0.25. Okay, so let us find the answer. It will be 0.32 to the power of 0.25. It is 0.752. 0.752. This is equal to 0.752. So 1 minus D is equal to 0.752. So D will be equal to 1 minus 0.752, which is equal to 1 minus 0.752 equal to 0.248. So this is equal to 0.248. And usually the depreciation rate is given in percentage. Therefore, we convert this D to percentage and it becomes D is equal to 24.8%. Okay. So our answer is, let me write over here, 24.8% yearly rate or per annum. Okay. This is our answer for this question. Okay. So students, this brings us to the end of this session. We'll be meeting very soon in our next session. Thank you for watching this video till the end. Please give this video a like in case you found it useful. Please subscribe to my YouTube channel. It will be motivating me to make more math videos which may be helping you in your math classes. And please do not forget to press the bell icon. You will be getting notified as soon as I publish a new video. So bye for now.